So remember the first pulse, goes here, gets echo, comes here, but then it goes back. The little portion goes back out.
Yeah.
And comes here and returns. And so eventually we get another pulse, a little smaller, but another delay rod pulse. So first delay rod signal, and then second delay rod signal.
Mm-hmm.
And this takes, we designed so that this takes 20 microseconds to do that. But we don't use these anyway. But that's basically, I wanted to show you how it works, So, and so that's what we're doing. So we need to align the transducer perpendicular to reflector. And so to make alignment easier, we put delay rod inside pipe, longer pipe. And then alignment ring. With alignment ring. And alignment ring has 3 screws.
Mm-hmm.
So if we look at
alignment ring 是什么？
alignment ring.
校正的环。
哦，校正环。
Yeah, like this is here alignment ring.
对，校正环，一个校正环。
So it's like a gun sight, like an army, like when you went to service army. Yeah. So long, so for better, more accuracy, more resolution.
Yeah.
Yeah. So we have three screws in alignment ring, 120 degrees apart. And so although on the sample cell for easier precision, we have maybe like one here, and one here, something like that. So 2 of them have a very fine thread, very high resolution, and then there's a bigger one, fatter, bigger one. And this one has a ball with a spring inside. So when you tighten these, the spring, moves. And that way you can tighten, you don't have to be at the same time because this moves in and out. So that way then you have your, pipe here. So you're moving the pipe. And so what you do is you have this touching the pipe, pushing a little bit, but not complete compressed, but touching so can push and compress. And so you move these 2. Move once, and then you look at attenuation. And you try to minimum attenuation. Minimum attenuation means this maximum amplitude, sample echo, maximum amplitude.
It's more easier for us to read, right?
And easier to read the number. Yeah, so, remember I said at 65 megahertz, below 15 is okay, it's good.
Okay.
So then what you do is you push this one, move this one, and look minimum, and then you move this one. Or either way, move one, minimum, and then move the other. And mistake that sometimes lab person makes is move one, move the other, finish. No. Move one, move the other, move the other, move the other like 4 times because you're moving like this. So so it's not just one position, but maybe you move this way, then this moves it this way, then this moves it this way, so you're going, so you want to move several times. And sometimes when you move, maybe this gets loose, not touch anymore, or maybe too little, or maybe compressed fully. So sometimes you have to move this a little.
Okay.
maybe half a turn. This is coarse, so these are fine thread, and this is coarse thread. Meaning not so much resolution, but you don't need. So like you see here, let's see. See, this one is very fine thread, see? And this one is now fat, see, coarse. And this has a screw inside. Spring inside. Yes. So that's how you align this.
Okay.
So when you have, when you have only one transducer element, then you align each one separately. But when you have combined two elements, then you can only align to one of them. So you align to the high frequency, which is more sensitive. Because the high, let's say this is the high frequency on this side, it's a very narrow beam. And low frequency is wider beam. So if it's a little misaligned is not so bad, not a problem. So you align with a high frequency.
So two elements, we just have to align one time. It's
Yes,
okay.
right.
The high frequency one.
The high frequency. You still do the two screws, back forth, like 3 times or so, 4 times. And after you finish alignment, and you say, okay, 13.7, finished. Then what you do is after you finish, then this one you tighten a little bit. Not too hard, but maybe just fully compress spring, because that way less chance to slide, especially when shipping to China. So we put some epoxy glue here, soft epoxy glue, and to prevent moving, and also we tighten the big screw a little bit, so that less chance for moving before it gets to your labo.
Okay.
Any questions?
No.
And so the most, one other comment, the most important surface is the rod, the delay rod, the quartz surface here, and the this surface on the reflector. This does not matter.
Yeah.
This doesn't matter. It can be dirty.
Yeah.
It's okay. Air.
Must be very clean.
Exactly. Clean and no air bubbles here or here.
Something. It means the paste must be very clean and no bubble.
Right. And no scratches.
No scratches.
Yeah, scratch here, okay. Scratch here, okay. Scratch here, bubble here, it's okay. But here the quartz and these two, yes.
Okay. Okay.
谢谢。
谢谢。